Welcome back, everyone, and in this video we're going to be taking a look at a couple of example problems using the area of the triangle formula, as well as, well, another area formula we'll use to solve for parallelograms. Let's go ahead and jump right in. So very similar to the area of the triangle that we were doing, the area of a parallelogram could also be given by A times B times the sine of C. Very similar where you're talking about two different sides that sandwich an angle. The only difference here is that you're not multiplying by 1/2 or dividing by 2. You're just kind of sort of leaving it alone. So let's go ahead and apply that. It actually is a very straightforward process. So let's find the area of the parallelogram ABCD. With BC is 7.4, AB is 12.3, and the angle of B is 39 degrees. Well, again, I have two sides, 1 and 2, that sandwich this angle. So I can go ahead and plug these values directly into my formula and solve. So my area of the parallelogram would just be 12.3 times 7.4, and that's going to be times the sine of 39 degrees. So just put that into your calculator, and as long as you're putting in everything correctly, you should go ahead and end up with the correct answer of 57.3 centimeters squared. Always good to include units and circle and box your answer. So just like that. Very simple formula. You just got to know what you're looking for, plug it in, especially in your calculator correctly, you'll go ahead and get the right answer. Now, let's take a look at a problem that might seem a little bit more difficult, but as long as we use the same steps as we did before, we'll find that it's just the same level of difficulty. So if we have a gazebo floor, and it's an octagon shape, now those edges of the octagon are going to be 1.2 meters, and it's going to be made of 8 congruent triangles, meaning that these triangles are essentially equal in area. So let's find the area of the floor. What it's asking for is that, well, the floor is basically this octagonal gazebo. It wants to know the area of this shape. So how can we do that? Well, if we know that this is going to be 1.2 right here, well, what else do we know about this? Well, we know that the distance from here to here and here to here are going to be equidistant. They're going to be equal just by the nature of this shape and what it is. What that means is that we are going to have an isosceles triangle. That's going to be important to remember. What we also have is basically in any circle we're going to have 360 degrees. But if you think about it, I'm splitting that 360 degrees into 1, 2, 3, 4, 5, 6, 7, 8 different sections. Equal sections because they're congruent. Now, if I took 360 and I divided it by 8, what is going to be my angle measurement? It's going to be 45 degrees. So what that means is that this angle in here is going to be 45 degrees. Now remember what I said about these being isosceles, triangle. What that means is that these two angles are equal to each other. So if 180 degrees is the sum of all interior angles, I know that one of them is 45, and I know that, well, whatever this angle is, if I multiply by 2 because there's 2 of them, this has to equal 180. So what I get at the very end of this is that this angle x, I'll call it x, doesn't matter what you call it, is going to be 67.5 degrees. So if I can zoom in on this shape again and clean it up a little bit, I have a 45-degree angle down here. And I have a 67.5 degree angle here and a 67.5 degree angle here. And that is going to be true for every single triangle that I have. Now, the question becomes, what do I need to find for the area of this entire figure? Well, let's start off by simply finding the area of one of these triangles, because the shape is just this triangle 8 times over, all the way up to 8. So I know that the area of any triangle is 1/2 2 of the sides that sandwich the angle multiply the sine of the angle that it's sandwiching. Now, I have what that angle is. It's 45 degrees or 67.5 degrees. That's fine. This is 1.2. I don't know what this is, and I don't know what this is. But that's not really a problem, because I can actually use a property from a previous video, link over here, or in the description down below, that can do that. What it is just the sine rule, because I want to know what my missing side is. I have 2 angles and then the corresponding side for one of those angles, so I can use this quite easily. I'm going to change colors real quick, and I'll go ahead and say that, okay, well, the sine of 45 degrees all over 1.2 can be equal to the sine of 67.5 all over, let's go ahead and call that missing side x. I'm going to rearrange for x, rearrange to solve for x, put that in my calculator, and get the answer. And what you will get is kind of a run-on number. You'll get 1.56787 ... meters. Okay, that's going to be the length of both of these sides here. So now that I know the length of that side, I can now use my area equation, because I know that the area is equal to 1/2. So one of the sides, we'll go ahead and call it 1.56787 here. And remember that when you're using your calculator, especially on the Ti-Nspire, there is that ANS, answer button. Go ahead and hit that, so that way you're using the real actual value in your calculation, not just the approximation, which can sometimes mess up your answer by a couple of decimal points or significant figures. And my other one is going to be 1.2, and that's going to be times the sine of the angle that it's sandwiching, which is 67.5. Right? And what you'll find is that area gives you an answer of, let me check my calculator as well, of 0.869117 or so. I'll go ahead and use the approximation. Problem is, that's just for one of the triangles. This is an octagonal shape, so I'm going to have to multiply that by 8. So if I multiply it by 8, I'm going to get my actual area, and to 3 significant figures, that's going to be 6.95 meters squared. Okay, so just to recap, I took all the information that I knew, that this was an isosceles triangle by the nature. 360 divided by 8 gave me an angle of 45. I had 1.2, and since all the angles here must be 180 degrees, I knew that 45 plus 2 of these must be 180. Found that out. I knew that I needed this side or this side, they're equivalent. I knew this side, and I knew all these angles, so I could just use the sine rule to figure out what this was. Then once I found the sine rule, I could use my area of a triangle formula using this side, and this angle, or you alternatively could have used this side, and this angle, because it sandwiches them, you'll get the same answer at the end, which gave me the area of this entire triangle here. Then I multiplied it by 8 to give me all 8 of the triangles in this octagonal shape, giving me my final area of 6.95. So that's how complicated things can get. So we can take a very simple formula, but with a little bit of context, it becomes a lot more difficult. But as long as you take it step by step and know exactly what it is that you're looking for, you're going to get the answer every time, as long as you are careful with your steps and you are isolating for the correct variables and, of course, putting in your calculator correctly. All right, take care, and I'll see you all in the next video.